Hi everyone. Welcome to my data analysis project video. In this project, I'll be analyzing customer behavior based on transactional data. The goal is to understand customer preferences, purchasing patterns, and overall behavior through exploratory data analysis, or EDA for short. Let's dive into the code and see how it all works. Importing libraries. To start off, I've imported a few essential libraries in Python that are commonly used for data analysis and visualization. The first library is Pandas. Pandas is a powerful data manipulation tool that helps us work with structured data like tables and spreadsheets. We'll be using it extensively to load, analyze, and manipulate our transactional data. Next, we have NumPy, which stands for Numerical Python. It's mainly used for performing mathematical operations and handling arrays. Although our focus here is more on data analysis, NumPy will be useful for certain operations like generating random numbers or performing numerical computations. For data visualization, I've imported Matplotlib. Specifically, I'm using the PyPlot module, which is a simple and easy-to-use interface for creating static, animated, and interactive visualizations in Python. Finally, I've included Seaborn. Seaborn is built on top of Matplotlib and offers a higher-level interface for creating visually appealing and informative statistical graphics. We'll use Seaborn to generate more complex and aesthetically pleasing visualizations. With these libraries in place, we're now equipped to start exploring our data and uncovering valuable insights about customer behavior. Loading the data. After setting up our environment with the necessary libraries, the next step is to load the data we'll be working with. Here, I'm using the pd_readxv function from the Pandas library to load our transactional data. The data is stored in a CSV file located on my computer. By loading it into a Pandas data frame, I can easily manipulate and analyze it. The data frame is stored in the variable df. To get a quick overview of the data, I've used the head function, which displays the first few rows of the data frame. This gives us an idea of the structure and contents of the data, such as the column names and some initial records. Now that we've loaded our data and taken a brief look at its structure, we can start diving into the exploratory data analysis to uncover valuable insights about customer behavior. Let's continue with the explanation for this line of code. This part is focused on understanding the size and dimensions of your dataset. After loading the data and getting an initial look at it, the next step is to understand the overall size and dimensions of our dataset. Here, I'm using the shape attribute of the data frame to find out the number of rows and columns in the dataset. The shape attribute returns a tuple where the first element represents the number of rows, which corresponds to individual records or transactions, and the second element represents the number of columns, which corresponds to the different variables or features in our data. Knowing the shape of the data is crucial because it gives us an idea of how much data we're dealing with and how many variables we have available for analysis. With this understanding, we can proceed to explore and analyze the data in more detail. Now that we've loaded the data and know its size, the next step is to delve deeper into the structure of our dataset. This involves getting an overview of the data, understanding the statistical properties of our numeric variables, and checking for any missing values. First, I've used the info method from Pandas to get a comprehensive overview of the data frame. This command provides us with crucial information such as the number of non-null entries in each column, the data types of each column, and the total memory usage. This is especially useful for identifying the types of data we're working with, whether they are integers, floats, objects, strings, etc., and for spotting any columns with missing data.